Hello everyone, welcome to a new video. In this session, we're going to talk about how to use visualization in data analytics. Now, in our previous sessions, we have focused mainly on the exploratory data analysis, which is the most popular use of plots and charts. However, it's not the only one. During the data analytics process, it is possible to use visualization at every single step. So in a typical data analytic project, we'll have data collection process, then there is a transformation and cleaning of our data, then we perform an analysis, the EDA. Then if you're going to create a model, you can train it, you validate the model, and then you use the model, you deploy it to make decisions. Now, it is possible to add visualizations throughout the complete process in these different stages, and that's what we're going to talk about today. Alright, so in the first step, in the data collection, we can use plots to check whether your data has some missing values or not, to monitor the incoming data. You can analyze the shape of your data and to check whether it's changing, if the shape is the same or if it's changing, because it's important, especially if you have a previously trained model. It's critical to monitor the way in which your data it's arriving, because sometimes there might be some drifts or changes in your data that will affect the performance of your models. So it's important in the data collection process to monitor that part. Now in the cleaning side, it is possible to spot outliers with box plots. So here we have some examples. In the first plot, this is just the complete data set. In the x-axis, we have the variables, the columns, and each row here it refers to the observations in our data set. Now, if you see that the column it's black, it means that you have every single observation has that value in the data set. Now you notice here there are two variables with missing values: the age and the camera, for example, here, it's almost empty. So this is just a way to represent your data in the cleaning stage. So you can make decisions here whether you want to keep the variable, maybe do some imputations, or if you're going to drop the variable. So for example here, the Kevin variable, it's like less than 50% of observations will have that value. So a good idea will be to just drop the column. That will depend, of course, of the context. In the second plot, we have a box plot here to identify some outliers. So remember, points that are outside the whiskers. So here we have two outliers. And the third plot represents the changes in our data. So maybe you train your model with some specific data, but in real life, what happens is there is change all the time. So it's possible that the distribution in some of the inputs or some of the variables are changing. Therefore, you need to keep track of that. You need to monitor if there are some changes, because they may affect the performance of your model or of your analysis. So here we have the input before and the input after sometimes. So there is a change, right? It's the value of the mean is increasing, and even the variance is changing. So it is important to always keep an eye on the inputs. All right, for data reduction and transformation. So data reduction refers to the process in where you have several variables, let's say 100 variables, thousands of variables, and sometimes in order to decrease the complexity of the processing when you want to train a model, you want to reduce the dimensionality of the problem. And also, when you're doing exploration, you want to visualize your data, but if you have multiple variables, that's an issue, especially because we can only plot 3 dimensions. But if you have hundreds of variables, that's going to be a challenge. So there are some techniques to reduce the dimensionality, and they are useful in order to visualize our data. Now, in the case of the transformation, Sometimes we apply transformations to our variables, y variables, and even independent variables, our x's. And that's important because sometimes they are skewed, so we try to apply some transformations in order to get more symmetrical variables. Because sometimes models require that the variables follow, some specific probability distributions. So in the first plot here, we have this is an easy case. We have like 3 dimensions, like 3 variables, right? But like if you perform like a PCA, which is the principal component analysis, or a similar method, you can reduce the dimensionality. So here with 2 variables or 2 components, 2 principal components, now we're representing the same data set. Now, it's important to mention, even though it's not the idea of this video, but it's important to mention that when you perform a dimensionality reduction, you lost some information, because it's not the same, of course, to represent your data in only 2 dimensions compared to 3 dimensions, or even if you have more, you will lose some information. So, but at the same time, you also will get an idea on how your data looks. For example, here in the 2 dimensional world, now you can see that there are like 3 groups or clusters. So that gives you an idea whether a classification model can be used here, or if it's non-supervised analysis, if it's an unsupervised analysis, if you can do clustering. So again, PCA, it's really useful at this point when you want to reduce your dimensionality to visualize your data. And in the second figure, we have we apply here a transformation. So this is the original data to the left, and then after a Box-Cox transformation, please note that the resulting probability distribution is more symmetrical. Visualization in EDA, we have discussed it a lot in our class. It's the most common use of visualization. So the main 2 ideas on why we use visualization in EDA mainly is to identify relationships between our variables. So we use different plots, remember scatter plots, box plots, to check the numerical variables and even the discrete variables, and identify if there are some relationships among our variables. Also, you have time series, then we will use some lines to check the trends, right? To see whether our variable is increasing, decreasing, or it's stable, or if there are some, if we have seasonality in our data. So that's why it is important to visualize. We have used multiple plots in our analysis, but here typically you will see bar charts, histograms, scatter plots, pair plots, density plots, like all the different options to to compare, to analyze variables. Now in the modeling part, so this is where when you are training a model, let's say a regression model or a classification or a time series, so you can use visualization also to first to check model performance. So classification, it's very typical to use a ROC curve, because it helps you to check, like to identify if you can get a good model with a specific method, especially when you're doing a binary classification. It's possible. Another use here in the modeling part is when we are analyzing the errors, right, or the residuals. For example, in a regression model, we check the residuals to see whether they are independent or not. So typically we use a plot for that. Or even when you want to check whether the residuals follow a normal distribution, you can use a QQ plot to evaluate that part. So here we have some examples. So in the left side we have it's the same figure. On top there is a confusion matrix to see, like, this is for a classification model. So the green part, the diagonal, it's for the classifications that are correct, and the red diagonal for the classifications that are wrong. So in the green diagonal is where our model it's working, right? And the problem it's in the red diagonal. And here we have this is an ROC curve, the ROC curve, and the idea is to get a model that will give you good prediction in high sensitivity and high specificity. So here we're trying to get the models that are, you know, like with a high sensitivity and a high specificity. So we will try to get models in this area. Let me draw it here, this area here. So these are the desired models in this area. You will find them here because where you have, you know, like the highest sensitivity and the highest specificity. All right. Now in the second figure here, this is a residual analysis. Let's say this is for it can be for any predictive model, but if you notice, if you check the residuals, you see that there is a pattern here. So if you're trying to, you want to check like if the residuals are independent, you will see that they are not independent in this case. Because if you're checking for independency, you want to see like randomness. But here there is a pattern. That means that your model is not capturing something in your data. It's not capturing some of the relationship in your data. That's why you see a pattern that is left in the residual. That's why you prefer, or the idea when you check the independency of residuals, you want to see complete randomness. It means that your model is working. But if you see a pattern, then your model is not capturing that. So it's a problem to have patterns in residuals in general, not just in regression. In other models, it's not good to have patterns in your data. Okay, after the model stage, we can also use visualization in the variable significance. This is to check the importance of variables. So which variables, which predictors are like more important in the prediction of our y variable or dependent variable. So you will see here some techniques like the future importance plots. This one. You will see this in random regression models, random forests for regression, for the classification. You will see this type of plots, or also some CHAP values. These are methods again to check like which variables are, you know, the most important variables in your model. There are some cases, or there are some models that are called like black box models. It means that it's not easy to just look at the model and find which is the most important variable. It's not like, for example, in the linear regression model, it's simple. You can see the importance of the variables. You check the slope, right? You can see that. But in some models, it's not that simple. You don't have a single equation. They are more complex. So you need some techniques to get what are the most important variables, and the future importance plots and CHAP values are really important for that purpose, and typically they use some plots to visualize the variable's importance. The predictions, when you are doing the deployment of the model for, you know, the users, you want them to start implementing the model and making decisions. So typically you will see some like dashboard or apps where the user will, you know, provide some inputs, you know, the X variables for the model, and then the user will get a prediction, which can be a single value or can be an interval, right? Depending on the model that you are providing. All right. So the conclusion here is visualization is gonna like enhance every step of data analytics. It's not just for the EDA. It can go beyond the EDA. It's critical for multiple stages in the whole process. So the advice here is that you need to start incorporating visualization in almost every single step of your workflow, because that will give you the opportunity to explain way better what you're doing, and even non-experts will follow your pipeline, from data collection until the results of your model. All right, so I'm gonna stop the video for today. I'll see you in our next session.